Okay, this is Brian Slocum from the Lehigh Design Labs, back with another Fusion tutorial. This is kind of an extension to a video I just posted that shows how to do different types of joints. We have a new mechanism project, and actually this is a student project that the student was having some trouble with, and so I thought this involves a couple different types of joints. And at the very end, I'll talk to you about dealing with these gears. The gears are problematic. There's no real way to make a joint between gears in Fusion, and so we have to use a different technique here at the end called enabling contact sets to make those guys work together. So we will get to that in just a second. So first, let's start by assembling this mechanism. Obviously, we have a lot of different components here. You can see my list. They're all different components. You'll note that they're actually, most of them are actually all brought in from another source. So I'm bringing in external components, and that's why they have this like link icon next to them. Some of them are copies of one another, and so we're going to start by creating some joints between these to get this mechanism moving to the degree that we can. Some of these, on first look, they look like pin slot joints would work really well, and that's actually been slightly problematic in this example. And so we're opting for a slider mechanism as well. And so what you'll see is the geometry here, if I zoom in, we have this little slider mechanism that's going to kind of be pinned at these holes. And this has an edge that allows us to create a slider joint rather than a pin slot joint. So that's a little nuanced difference there. I can't say I truly understand why the pin slot solution does not work. What I do know is that it doesn't, or at least it creates errors that I am unable to resolve. So hence the way that we're going to approach this slightly differently. All right, so let's get started putting this thing together. So we have this drive wheel that's going to get mounted to this hole. That's a really easy joint, so I'm going to go ahead and start with that one. We're going to create a joint. The motion type here is going to be a revolute. We're going to use a simple selection here of the center point of the hole. So I'm going to rotate around the back side of this. Again, I'm on a Mac, so I'm holding down Command once I'm highlighted the face and find that center. And it turns transparent, letting me know that I cannot do that again with this object. I cannot create another joint can't create a joint on its own object. And then I'm going to come up here to the base plate and again hold down Command and lock it to that center point there. Lo and behold, we have that lovely thing, and if I click OK, oh, hey, what did Brian forget to do? As I talked about in my previous video, I've created a joint, but this thing is still free motion in space. It's because I never locked it down. So I need to ground my base plate, so I'm going to right-click on top of my base plate, and I'm going to ground to parent, super terrific. And now once I do that, once my computer catches up, lo and behold, I have that revolute joint around that center axis. Perfect. So that solves that first joint. The next thing I really want to deal with is I want to get this thing spinning, and this thing revolves around this center point here and this center point here. There's a revolute joint there, but the problem is I can't easily create that revolute joint. I'd have to, because their two faces won't meet. I could create a revolute joint and use an offset of the thickness of the material, but it's super helpful sometimes to be able to visualize how this thing is assembled in real life. So in real life, I would use a spacer there, and so I'm going to go ahead and use a spacer that is the appropriate thickness to offset this guy, the appropriate distance. And that spacer could be a rigid joint, and then I can do a revolute joint, or I can do two revolute joints, 6 of one, half dozen of the other. I think I might be using more computing power if I make a revolute joint, but it's the thing that I want this to behave just like it would if I were in real world environment, in which case if I have a round washer and I put a bolt through that round washer, that washer is going to be able to spin. So we're going to create another joint here with one of these spacers. The motion is revolute, just check on that. It is. And I'm going to go ahead and rotate over, find the bottom of my spacer, and choose the center point. And we'll rotate back over. And we'll choose the center point here. Super terrific. Okay, so that spacer's in place. And now I can create a revolute joint about that same center hole between here and here. So I'm going to do another joint. Still a revolute position. So I'm going to go to the bottom of this, zoom in, and that point. And come up here and choose the top surface here. I'll move over and show me that that rotates. Excellent, super terrific. Thank you so much, Fusion, for giving me an understanding of how that now moves. So these guys now move together. So this moves here like this. This rotates here like this. That's how it works. That's how I want it to work. Now I need to create the way that this thing will slide up and down based on relationship between this rotating wheel and this center rotator. So I need my slider for that, and so I have my little slider for that right here. I'm going to use a revolute, another revolute joint to pin this slider to my circle. And I'm cheating here. The circle's obviously way too big. I had kind of designed it for a pin when I was attempting a pin slot option. The pin didn't work, and so that's why I'm using this like slider option instead. Should I go back and change the size of my hole? Absolutely. Am I going to do that? Well, not right at the moment. We can always update these things later because these things are all linked. So I'm going to come over here. I'm going to create a joint. This time I'm going to go to the bottom. And this is what I'm saying is that hole is huge. This hole is small. But because I'm going to use the center points of the hole, Fusion is either not smart enough or doesn't care enough to tell us that, like, oh, your hole is too small. And then I'm going to find this top surface, hold down Command, and select my center point, and that's going to move that guy over and show me that it has a revolute. All right, super terrific. Now I need to create, I'm going to click OK to accept that, looks good. Now I need to create the slider relationship, which is going to constrain it along a single axis between this slider and this center bit, right? So again, it's a new joint. I'm going to switch over to motion now, and I'm going to, instead of revolute or pin slot, I'm going to choose slider. And I'm going to go back to my position. I'm still using simple, but watch. This is the first example I've used that I'm not going to use. I'm going to use, actually, see this? I might have to zoom in here a little bit. I'm going to choose the center point along this edge. And I can only do this because these edges line up. I'm going to choose the center point along this edge. Bink. And I'm going to choose the mating center on this edge. And because I'm choosing edges, that's going to appropriate an axis for the slider to move upon. So I'm going to choose that center point. And you'll see that when I do that, that allows this slider to hopefully work the way I want it to. So click OK. And let's see if this constrains it the way I want it to. Oh, yay, it does. Now, this is the exact reason why I would want to do this in Fusion before I go ahead and start making my parts. Because if I rotate this thing around to the extreme, kind of like going till this thing is perpendicular, and I look at a top view of my object, and I zoom in, oh, hello. I either need to change center points, or I need to make this slider smaller, or I need to extend the length of this rotator to allow, because right now this would preclude this motion from happening because the slider would hit this. These two things are existing in the same space. That obviously can't happen in a real world scenario. So this is illustrating for me that that motion issue is going to cause problems if I keep everything sized the way I have it here. And then let's look at the other side of this when I'm fully in the down position. Oh, and you can see, oh, like actually that slot is way too long. It doesn't need to be that long. So I can either, I have an option of like moving this center point closer to the circle, which would shift this whole thing up, or just making this thing longer. Either of those are options. But this is highlighting for me, this is the reason why we would do this in a virtual environment. It's highlighting for me that if I make these parts, I pin them where they are, this will not function as intended. So great example there of the why behind of why we do this. All right, so that gives us that slider. We're going to repeat that same slider solution here with this bottom thing that tracks these teeth. Here's my base plate with the holes. Again, this piece needs to be at the same plane as the yellow piece so that the gears can mesh. So I need to add those spacers here at those holes. This is going to be largely a repeat of what we did before. So I'm going to assemble with a joint. I'm going to go to a simple revolute joint. I'm going to select one of the spacers, bottom center here. Oh, got to go to position. That's why I'm not getting a selection set. There we go. Command, choose U, revolve around, and we'll choose U. Good, super terrific, looks great. Do the same thing for the other one. And joint, center of U, think, rotate around. We'll choose the center of U, think. Okay, looks great. And then my slider, just like this slider up here, is going to be another revolute based upon the center point that lines up with the center point. So I have to do that 2 more times. Joint, revolute is good, so I can join those centers. This time I'm going to choose this center point here. And this center point here. Great. We can see it revolving around there. Super terrific. And do that 1 more time before we get into the fun joy of the slider. Joint. We're going to capture U from here. And last but not least, here over here. All right, so that sets up everything I need to get this thing sliding back and forth. This is the same thing I did last with this. I'm going to choose an edge. I'm going to choose the center of an edge to create that slider in that joint. So joint, motion type, we're going to go back to the slider option. Position here, I'm going to choose on this edge, that center point. Right there on that edge, on the bottom edge. And then I need a corresponding edge to that, which is actually going to be the bottom edge here. So I got to twirl around in space until I get to that edge. And there we go. We want that point there. And it's going to show me how that works. That looks great. And there we go. Oh, ha. I've given you a little preview here. I thought I had turned this off. So pretend nothing happened. I'm going to turn this off. So up here under Assemble, we have a thing called Contact Sets. I'm going to click Disable Contact, and you'll see that goes away. If I go to Assemble, I can enable Contact Sets. So the reason I'm doing this is because as I move this, if this is disabled, right, you can see like, oh, Fusion doesn't know that these things are actual, like have physical presence, right? And so in this scenario, it won't let these, it won't let these things interact. So, oh, it would seem like we need a joint there, but there's no joint between gear teeth. So I'm going to actually go to the most extreme position here, and I'm going to slide this guy over. So you can see this is constrained now. I'm going to slide this over. So we have some gear interaction here. Looking here at this face. So this is the most extreme position this way, and so I want this thing to be able to shoot back across my screen that way. So I'm going to set this up so it's positioned that way. And now I'm going to enable contact sets, and I kind of gave you a clue of what that does. But I'm going to click Enable Contact Sets. I'm not going to do all because that would, my computer would die with how it would have to crunch all of the calculations for these things. And under Contact Sets, it pops this up in my browser. I'm going to right-click on that and I'm going to say new contact set. And it's literally just asking, like, what do you want to create a contact set between? And I'm going to say I want to create a contact set between my center rotator, this yellow piece, and my slider, this gray piece. And then I click OK. And what that's going to do is it's going to look for physical interference between these two parts. So it's essentially saying these two things can no longer inhabit the same space. They have to be separate. And so when I do that, that's essentially like creating a joint. It's just making this thing exist in the physical realm. And so you can see what's happening is as I rotate this, we're seeing that motion happen. One caveat about this, go slow with your motion, because the computer has to calculate the interaction of these pieces every single time. And if you go too fast, you can rotate to the point so quickly that it can't do the calculations, and then parts will actually slip through one another and you won't get a good sense of motion. Now, I want to zoom in here. Let's see if I can track this down so we can see the whole thing. This is a great way of looking at backlash in gears, actually, because you can see if I rotate this wheel, I have all of this motion that happens before I start to see corresponding motion in my other piece. And it's because there's like that, all that slop in the gear. So what that means for me, as I go back to reinvestigate this, again, another reason why we'd want to do this in the computer, what this means for me is that I would want to move these things, either I'd want to change the size of the gear teeth, or I want to get these things closer together. If I pull this gear tooth further up into this void, these faces are going to be much closer together, and then we're not going to get that like slop in my gear set. So just, it's a really good idea here to do this. And the lovely thing about doing this as components is we can, and see, there we go. I just went too fast for my computer, and these things slipped through each other, and now that contact set doesn't work. And so actually to get it back where I want it to go, I'd either have to move it super fast, like can I move it fast enough to get it back? There we go. And then reset it. So you can go back and do it if you screwed up, but you don't want to go too fast because your computer's doing all those calculations. So it's a really great way to examine these. It's not a foolproof method by which to do that. And the other thing this highlights for me too here is that, this thing is like, either my slots are the wrong length or something, or I'm too far over because now we have this issue. So maybe I want to enable contact sets between these two things, or set motion limits of that joint. So I could do that here. I could go here and set edit motion limits, and I could change how far that thing could move left and right. So there's options for getting around that as well. All right, so I'm going to end it here. Hopefully that was exciting for you to see how this comes together and how we can use this to prototype virtually before we prototype physically. Thanks so much for tuning in.